Okay, so this warm-up is with, bless you, a parent function of what? Natural log of x, right? Tomorrow we'll warm up with the e to the x one, so that you have an example of one of each, because remember, these will be your free response questions. So you should be thinking parent function transformation, and you should envision in your head the starting shape of our graph, right? The natural log of x is log base what? E, right? So it passes through the point 1, 0. It also passes, for what it's worth, through the point e comma what? 0. Well, it passes through 1, 0. What is the natural log of e? I told you that's the other one you need to remember. 1, right? So you don't really need to put that there, but it's good review, and I'll go ahead and go through it. So that's what it looks like. That's your parent function, natural log of x. I guess I should have written this and color-coded it. There we go. Now it's color-coded. All right, so we're going to transform that. Probably the most important transformations are what when it comes to this one? Is a vertical shift significant? Not. Vertical shift is okay, but it's not super significant. Which shift is actually more significant? The horizontal, because that's going to move your what? Your intercept, of course, and the asymptote, right? And then, of course, what other transformations? Your vertical stretches and compressions and horizontal dilations, not really important, but there are two others. Reflections, yeah, either x-axis or y-axis are important. Really, the y-axis is even more important because that's going to get your graph on the other side of the asymptote when it comes to your domain. So anyway, once you identify the parent function, part A is to put it into standard transformation form. So let's go ahead and do that. I have it written down here. Boom, there's your parent function. Okay, so the 7/5 in the front must go where? In the back. So that's 3/4 times the natural log of, and I'll leave that open, positive 7/5. Okay. I'll give you one check for having that at the back. That's kind of nice of me. You're welcome. At the back. Oops, spell that correctly. And then on the inside, remember, is where it's at. So you want to have your x term first. So I commute the terms. Is that it? Very good. We have to contend with the -3 in there. So that's going to be the natural log of, and remember, we have to factor that out. So if we factor out whatever the coefficient of x is on the inside, we have -3 times. Of course, that's x, and it will change the sign. What are we left with when we divide out a 3 from a 5/4? What's 5/4 divided by 3? Or a third of 5/4? 5/12. There you go. 5/12. So remember, if you don't know what you're doing, go off to the side and say, okay, 5/4 is what we're starting with. We're dividing out a -3. That's what factoring out is. Put the -3 over 1, and then do what? Stay, change, flip. And for multiplication, you just add or multiply straight across. So I'm going to give you a second check for having that on the inside there. Okay, so that is standard transformation form. You should have f of x equating it somewhere. So if it's not in front of there, at least you had it written and you worked down with the equals lining up. Okay, so part B then said, find the simplified exact value of the y-intercept. Show the work that leads to your answer. So how do we communicate that we're finding a y-intercept? F of. Yeah, f of what? 0. F of 0 equals, so that's going to be the third check that indicates your method. F of 0 equals. And then we can plug into any version. I'll probably plug in to the very top one, 7/5 plus 3/4 times the natural log of 5/4. All right, so this answer here is your fourth check. Or you could have plugged it into the standard transformation one. But remember, that one is only really good for transforming into something that's sketchable. The other version is a little bit easier. right? So the notation is important. So you could also earn it like this. If you write it as an ordered pair, 0, comma, and then you have it 7/5 plus 3/4 natural log of 5/4. I'll let this be the third check, and then this could be the fourth check. Okay, because that also kind of indicates what you're doing. It shows that you're plugging in a 0 for x. All right, letter C. Letter C is for cookie. What? Mm-hmm. Yeah, that's what this is. Yeah. Yeah, I mean, what would you do to it, George? It's certainly exact. Simplify is kind of an arbitrary thing. If you wanted to do anything, because there's a log there, you could do one of two things. It's still going to be 7/5, but you could bring the 3/4 up and say it's the natural log of 5/4 to the 3/4 power, and then take the fourth root of that cubed, because then that would end up being plus the natural log of the fourth root of 5 cubed is 125, and then 4 cubed is, 64? So if you did that, what's that, the question? Oh, I plug in a 0 for x, right? 3 times 0 is 0, and 5/4 minus 0 is 0. Yeah, that's how you find Y-intercepts. So that's one way to simplify if you wanted to do it that way, but without a calculator, we can't get much further. The other way is to go 7/5 plus 3/4, and then we could expand this out with parentheses. That's the natural log of 5 minus the natural log of 4, right? We can expand that, and then if I distribute, I get 7/5 plus 3/4 natural log of 5 minus 3/4 natural log of 4. So that could also be simplified. But really, we can't evaluate it. So if you have either one of those, or you left it like this, that's okay. All right? Okay, good question, though. Part C, then, is to find the, or sketch. Sketch. Okay, sketch. So this is where our standard transformation form is handy. So let's grab that, paste it down below for part C. Extra parentheses. Okay, so part C. Let's see how we could do this. The 3/4 in front, that's not really significant. That's just going to be a vertical what? 3/4 is less than 1, so that's going to be a vertical compression by a factor of 4/3, right? 1.333 times shorter. So that's not a big deal. The 3 in front of the x is going to be a horizontal what? Minus the negative. The 3 in front of the x is a horizontal compression by a factor of 3. The negative is super important, though, right? Because what is that going to do? It's going to flip it across the y-axis, right? So now our graph is going to live where? To the left or right of it? To the left. It's going to kind of look like this. Let me draw it. I'll draw it lightly. Remember, we never have to show the stretches. It's going to look like that. And then the plus 7/5 just moves it up 7/5, but the minus 5/12 is significant because that does what? It moves the vertical asymptote from 0 to where? To 5/12, yeah, to the right. So at 5/12, you can go ahead and just label it, put a vertical asymptote, and now you know that the shape looks like that, don't you? That green thing is just decreasing to the left. So let's just draw it like that, decreasing to the left. Oops, held it too long. Okay, so there's Coach Fair. Hi, Coach Fair. Going well. We're playing with logs today. Yep. Okay, so now remember, if there is the risk of crossing the y-axis, you need to make sure you're crossing it either in the correct positive or negative land. So here's how we're going to score this graph. We're on check number 5. You're going to get one check, check number 5, for having a vertical asymptote at x equals positive 5/12. Okay, that's the 5th check. You're going to have a 6th check for having your graph decreasing on the left side of the VA. So if you have your vertical asymptote in the wrong spot, but it's still decreasing on the left-hand side, you can get the 6th check. Okay? And now there's one more check, the 7th check. We just found this right there. Is that a positive or a negative number? Positive? Why? Are you guessing? Okay. When we take the natural log of 5/4, we don't know what the number actually is, but 5/4 is bigger than 1, right? And if the natural log of 1 is 0, 5/4 is going to be like 1.25. It'll be right here. What type of value is that? Yeah, that's going to be 5/4 comma natural log of 5/4. So we know that the natural log of 5/4 is greater than 0. It's positive. Okay, so why is that important? Well, as long as you know it's positive, you can figure out what the Y-intercept is. So it's a positive number times 3/4, which is a positive number, and then 7/5 plus a positive number is positive, right? So what that means is that 7/5 plus 3/4 natural log of 5/4 is also greater than 0. So it should be crossing in positive land. Okay, so that's the 7th check. The graph crosses in y equals positive land. There you go. Crosses in positive land. So if you have it drawn all kind of wacky doodly, but you have it crossing in positive land one time, give yourself the 7th check. Well done. Could have gotten lucky, but that's okay. People who win the lottery are lucky. Okay, so that takes care of the graph. Now, the domain, D, find the domain. What's the domain? Yeah, very good. It's going to be the set of all x such that x is less than 5/12 or negative infinity parenthesis to 5/12 parenthesis. That's going to be the 8th check. Eighth check. Okay. Now you could have found that algebraically. Yes, yes. Just remember for the test, and there's one on the practice test, we can only solve inequalities algebraically if they're linear. 5/4 minus 3x is linear. You basically take your argument, whatever it is, and you say it's strictly greater than 0. So 5/4 minus, bad memory, 3x, yeah. Bless you. Has to be strictly greater than 0. Is that linear? Yeah, so can I solve that algebraically? Morning, Coach. Happy National Cookie Day. That's why I hate to announce it, because everyone's always been expecting cookies. But if you go to your web browser and you leave cookies on, then all day long, wherever you surf, you get cookies. Yeah, so those are the free ones. Yep. All right, so you bring the 3x to the other side, and now you divide through by 3, and you get 5/12 is greater than x. But then you flip it around, you get x is less than 5/12. Is that consistent with what we found graphically? Yep, sure is. So that's another way to find the domain. And it's good to compare the two, yeah? Because they should be the same. If not, something happened. All right, A, B, C, D, E comes next. I know my alphabet. What rhymes with next? Plexed? Perplexed? Flex. Oh. Darrow on Corpy just flexed. Okay, what is the range? All real numbers. Yeah, so you could do that, or negative infinity to infinity, or the set of all x such that x is an element of the real numbers. Any one of those. That's check number 9. All day long, all real numbers. Okay, and then, man, when is this going to end? Letter F. Find the equation of any of all asymptotes. Be sure to label which type they are. Ooh, which type they are. Okay, F. What type do we have? A vertical asymptote at x equals 5/12. That's simple. VA at X equals. If you miss any of that, you miss the question. Just to say what type they are. Remember, exponentials have horizontal asymptotes, and therefore logs have vertical asymptotes. Those are inverses of each other. And then finally, the last one, last and probably least, the limit as X goes to negative infinity. All right, so let's write that. The limit as X goes to negative infinity of this function. Well, since you have the graph, just hop on the graph and head out to the left, and where is you heading? You're going up, 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 up forever and ever and ever. So infinity, or what's another acceptable but less desirable answer? D and E. Yeah. But I'll accept either one of those because this is kind of a short answer for your response type thing. On a quiz or something, I would expect you to know infinity. I would not accept D and E. And on a multiple choice question, of course, I would not have non-existent or D and E as an answer choice. So you'd have to know what type of infinity. All right, so there it is. That's 11 checks. Bless you. I know that comes out to 9 points apiece, but let's have a little sale on points. Let's do 6 points apiece. No, let's do 5 points apiece. There you go. All right, so that's a practice quiz, all right, for tomorrow. So you can kind of score it and see how you would have done. Well, not quiz. I don't think we'll quiz tomorrow after all. We need to kind of keep going and get ready for the test. But you'll have a warm-up like this tomorrow. And if this were a test question, we probably wouldn't make it worth 11. We'd pare it down so that it was about 9. We'd like to keep the free response the same as the multiple choice. But any of these things could be assigned points. All right, so you can figure out what your grade would have been had this been a quiz. All right, so any questions on that warm-up / practice quiz / goodness? No? Okay. Well, let us proceed. We're going to skip around, skip up, and skip down. Skip, everybody. Skip. Okay, we're going to skip example 4 and example 5 and 6, and we're going to jump to example 7. Because these are kind of where it gets real fun. All right? Solve the following log equations. Solve the following log equations. Okay. You always want to be mindful of your argument when you have a log function. Why is that? Especially with a variable. What? Yeah, we did all the way to 7. Skip. Why is it important to consider the argument if there's a variable in it behind the log? Because certain values of X, when you plug them in, may make that thing what? Negative. Or 0, right? Those are the two types of numbers that don't work with logs. We can't take log base 3 of a negative number, and we can't take log base 3 of 0. So that's important because, remember, sometimes you've had experience with this. We've talked about it. In the process of solving, you can generate what type of solutions that don't work? Extraneous, right? And that usually happens when you raise the degree of the problem, right? We've already seen that before. So let's say that we had a linear function like this. It's like an x to the first. It's of the form mx plus b. Lines can only have one x-intercept, yeah? But if you raise the power, like made it x squared, it might look something like that. So it might help you solve it. You're still going to have one of those solutions, but guess what? This one would be extraneous. All right, so notice your argument is linear. It's x to the first. You see that? So in the process of solving, if that degree ever jumps up to something larger than 1, we need to be especially aware of the potential for it being extraneous. So let's just go ahead and solve this, and then I'll get you in the habit of checking your answers at the end. You're already in that habit, I know. So we want to solve. What should we do first? Yeah, very good. If this were algebra again, this term would be like x. It'd be 4 plus x equals 16. And you'd be like, I've got to get the x by itself, so I've got to subtract the 4. It's the same thing. The term that has the variable in it is what you want to isolate. All right, so you subtract 4, you get 3 log base 3 of 2x equals 16 minus 4, which is 12. Good. Now that we've isolated the variable factor, we need to keep peeling back the layers so we can get it to 2x. What's the next layer we need to peel back? The 3. It's currently being multiplied. How do we undo multiplication? Divide. So we divide both sides by 3, and it divides out on the left. And we get log base 3 of 2x equals 12/3, which is 4. Peeling back the layers. Peeling back the layers. Your dear Aunt Sally's rules in reverse. All right, so now the 2x is trapped in the argument, so we need to get rid of the log base 3 in front of it. What is the inverse operation of logging base 3? Exponentiating base 3. Or you could either say 3 to the that equals 3 to the that, or we talked about going around the world. Yes? You can say 3 to the 4th power equals 2x. Okay? However you want to do it. I'm going to go ahead and exponentiate both sides base 3. So you just write them in the bottom left, and then those things that we had become the exponent. That's kind of like getting the bases the same in reverse, right? Yeah. Okay, so now what do you think 3 of log base 3 of blob is? Blob, whatever it is. That's 2x in this case. And you get 3 to the 4th. 3 to the 4th is 81. Man, y'all are fast with that. That's good. I think at the beginning of the year, y'all would have been like 12. Right? Right, but not today. No way. All right, and so now we're almost there. You divide through by 2, and you get 81 halves. 81 halves. Yay. And there's your answer, 81 halves. You don't need to box it up. If it's the last line, we assume it's the answer. Now, if you do want to box it up, I understand. Box it up. Oops, don't mess up the answer, though. Box it up. Looks something like this, right? And that way you can put kind of like a ribbon on it, you know, like that, and then a bow. And then you can give it to a friend. Hey, Merry Christmas. I love you. And they're like, oh. Okay. Don't use transparent boxes like that, because then they can see what's inside. Oh, actually, you know what? You might also have to punch some holes in the box so that the equation can breathe. Okay? All right. We should check our answer. Let's check our answer. If you plug 81 halves back in up here for x, the first thing you do is multiply it by 2, right? What's 2 times 81 halves? 81. And what type of number is 81? Positive. Excellent. That's all we care about. We don't care what the number actually is. It just has to be a positive number. If you wanted to continue working it out, that's great. So does 81 halves work? Yes. Okay, so we'll just leave it. All right, Merry Christmas. All right, comments or questions on that? Peel back the layers. Inch by inch, it's a cinch. Letter B. Boy. We got 2 logs, 2 different arguments, x plus 2, x minus 1. I need to get it down to a single x, which means I need to get it down to a single log. If I have log base what? What's the base there of both logs? 10. If I have 2 log base 10s that are added, what could I do to, what's a good word? Condense it down to a single log. Condense it, yeah. So that's going to be pulling 1. Ooh, I don't want to use black. Let's use a grease. Log, it's not that good either. I need to update so I can make some colors like y'all have. All right, so how about log? We pull 1 log out. What are we going to do with those 2 arguments? Multiply them, divide them, squish them together? Multiply them because they're both positive. So that's x plus 2 times x minus 1. Then you can do a little remodeling here. There we go. Equals what? 1, right? Still 1. Okay, so now you've isolated the log, right? What did we do last time when we isolated the log after we divided through by 3? We unlogged it, right? I need to get at those x's inside. So how do I unlog base 10? And exponentiate base 10. Or you go around the world. Okay, so that's 10 to the blob equals 10 to the blob. Now, what is 10 to the log base 10 of blob? It's blob, so it's going to be that. Let's go ahead and expand it out as we write it down, okay? Foiling it out, you get x squared, and then you get a 2x on the inside, a minus 1x on the outside. That gives you a positive x in the middle, and then 2 times negative 1 is negative 2. So that's expanding it out. And on the right side, we get 10 to the first, which is 10. Now, at this point, you should go on some kind of heightened alert. Yes, excellent. Here's my version of the red flag, right? You should be on a red flag alert for extraneous solutions. Ooh, look at the way I spelt that. I spelt that the millennial way. Extraneous solutions, okay? Because notice both of our arguments started off as x to the first, which are linear. Yeah? But now it turned into a quadratic. So this situation that was right here is possibly going to happen. But we're going to check it every time anyway. So how would you solve an equation like this if it were equal to 10? You have squared, non-squared, and constant. Do you move the negative 2 to the right with the 10? You could, but remember you have an x squared and an x term. If it were just an x squared and no x term, you could separate the x squared from the 10 and then extract the square roots. But if you have a squared term, a non-squared term, and a constant, you have to get it equal to 0 so that you can factor, or at the very least, quadratic formula. So x squared plus x, bring the 10 across, it becomes minus 10. Minus 2 minus 10 is minus 12. And now it equals 0. Make sure you show that. Does this one factor? Please say yes. I hope it does. Keep it equal to 0. Yeah, x squared is x and x. Factors of negative 12 that add up to positive 1, the middle term linear coefficient. 11 and 12? 4 and 3. Which one's positive? The 4 has to be positive because the sum is positive in the middle, and then the negative 3 has to be, or the 3 has to be negative because the product's negative. Okay? So from there, you don't have to show me that you're setting each factor equal to 0. That would be the zero product property. At this level, when you have it factored equal to 0, you could just go straight to your solutions, right? 4 and negative 3. Yeah? Criminy. If you plug your 4 back in, you get 4 plus 4 is 8. Oops. Right. Don't make the mistake that if you're not setting each one equal to 0 and physically solving for x, that you don't get these wrong, okay? It's negative 4 and positive 3. Now, if you walked away right here, you would be kind of, that would be very unfortunate because we are on red flag alert. So get in the habit for any log equation, just get in the habit of checking by plugging those back into where? Do we plug it back into this line here? No, that's already a quadratic. You got to plug it back into the OG right there, baby. Okay? So let's try it. Let's plug in our negative 4. He's the first one listed. You plug it into the argument and you get negative 4 plus 2, which is negative. Who cares? It's negative. It has to work in both. If it doesn't work in both, it's out. So go ahead and draw a line through it like that to show me that you're not including it, but don't obliterate it. It may give you satisfaction, but I need to see what was underneath there. I need to see that you considered it, okay? And now let's try out the 3. We'll plug it into the first argument. 3 plus 2 is what type of 5? Positive, so it passes the first argument. Second argument, 3 minus 1 is what type of 2? Positive. So guess what? The solution is x equals 3. And that's how you could leave it. If you draw an x to the negative 4, I know that you considered it, tried it out, and then omitted it. The 3 showed up, you tried it out, it worked, you left it. It's perfect, okay? Excellent. So extraneous solutions may occur. Especially be on the lookout, especially for the special case when linears become quadratics. Okay, comments or questions on that, hombre? Let's try one more. Let's see how far we can get. This one, we have 2 logs. They're both x minus 5. We need to condense it, or we could do what first? What do you notice? Simplify early and often. If they are both base 4 and the arguments are the same, those are actually like terms, aren't they? We have 2 of those minus 3 of those. So look for that. If they're both those and those are the same, those are like terms. So what is 2 of those minus 3 of those? Negative 1 of those being log base 4 of x minus 5. So that's kind of a neat way. and it equals 1. So now we just have a single log. What do we do to get rid of that negative? Multiply both sides by -1 or divide both sides by -1, right? Remember, once you get the log isolated, you need to clear it out. Multiply or divide both sides by that. So we get a -1 on the right. And now that we've got the log by itself, now we can either exponentiate both sides, base what? 4, or we could go around the world. I'll do the around the world one here. Just don't show the loops. That's kind of weird if you show the loops. Just imagine them. It's 4 to the -1st equals x minus 5. Now, is 4 to the -1st the same as -4? No. Has anyone ever done that? Yes. And I think they were trying to be funny, but it gives me a heart attack. 4 to the -1st is actually what? 1/4. So I'm going to switch sides here. 1/4 equals x minus 5, like that. And then I add 5 to both sides. What's 5 plus a fourth? How many fourths? 21/4. Or that's 5 is 24ths, plus 1 is 21/4. Yeah, or you could go 5 and 1/4. You remember good old mixed numbers? Good old mixed numbers, 5 and a fourth. And then you converted, bless you, by going 5 times 4 is 20, plus the 1, bless you, that's 21, bless you, fourth, bless you. You're welcome, bless you. All right, so our answer is 21/4. We don't need to box it or anything. It's the bottom line. We walk away. Let's try it out. 21/4 minus 5. Well, 21/4 is the decimal is what? 5.25. It's bigger than 5. That's all we care about, right? 21 divided by 4 is 5 point something. What's 5 point something minus 5? What type of number? Positive. It works in both. He's in the club. Welcome to the club, dude. So we didn't get an extraneous solution that time. All right, we'll stop right there, and then tomorrow we will spend most of the period finishing those up, D, E, F, G, H, I, and then we'll talk about the test. Okay, remember the test now is no calculator at all, and the free response will be like the warm-up, graphing. Tomorrow we'll do one with E, okay? All right, have a fantastic rest of your National Cookie Day.
I'm really sad we didn't have cookies.
Yeah, I know. Today would have been a good day to eat cookies or play the C is for Cookie song.